Catalysts. A catalyst speeds up a reaction by providing a different mechanism with a lower energy of activation. We've talked about that already. It's not consumed. It's regenerated at the end of the reaction. So a typical mechanism that involves a catalyst would be a lot of those reactions going on in biological systems, in living systems. They're catalyzed by uh, large molecules, protein molecules called enzymes. Okay, so those enzyme catalyzed reactions. Typical mechanism for those is you have an enzyme. What it does is it binds a substrate. A substrate is the reactant. Okay, so it's a molecule that gets bound to your enzyme, and then by being bound to the enzyme, it undergoes a change, and so when it's transformed into a product, it's released by the enzyme. Okay, so you'll notice in this particular case, okay, your enzyme is bound to the subscript, but then in the end, it's released back. So overall, what's the reaction here? Enzyme plus substrate gives you enzyme substrate complex. And then the enzyme substrate complex will give you back the enzyme and a product. So if you add these two, you have that cancels out. So you have substrate turns into product. Okay, your substrate would be your reactant. So that's your overall reaction. Okay. Here's mechanism for the destruction of ozone. Proposed mechanism. You have a molecule collides with an ozone molecule, gives you MO plus O2. Okay. So M here could be any molecule. Right. And then you have the MO here collides with an oxygen to give you back O2, to give you O2, and that's a fast step, and it re-releases the M. Okay. So if this was the mechanism, what's your overall reaction? M over M plus O3 gives you MO plus O2, and then MO plus O gives you M plus O2. If I add these two up, what do I get? Your MO cancels out, right? And your M cancels out. So the net reaction that you're getting here is what? O3 plus O gives you two O2s, right? That's your overall reaction. So in this mechanism, what are the reactants? O3 and O, right? Those are your reactants. What is the catalyst? M is a catalyst. What is the product? O2 is your product. What is the reaction intermediate? MO. And what's the rate law? What's the rate law? The rate, what's the rate determining step? The slow step. So the rate law would be equal to will be the rate law for the slow step. So rate is equal to K times M times O3. Okay. What is the overall order of this reaction? Second order. What's the molecularity of the first step? How many molecules are involved in the first step? Two. So the first step is bimolecular. Okay. What's the molecularity of the second step? Also two, bimolecular. Although you might say that's an atom. When we talk about molecularity, we'll treat an atom as though it's a molecule. Okay, so that's also bimolecular. Right? And that's it for that lesson.